This is chapter 8-5, proving triangles are similar. Please copy your cuts. I believe this section should be rather simple for y'all. I'm not trying to insult your intelligence, but this is related to some old things that we've done in the past. Similar triangles, similar polygons, and triangles, of course, are polygons, three-sided. How can we relate that they're similar? Well, two theorems we're going to look at. The first theorem we're going to look at is Theorem 8-2, which is the side similarity theorem. If you remember before, we did side for two triangles when we said they were congruent. Okay? Congruent, remember, means same size, same shape. We can use side again, but this time, and I'll write it in a different color. But this time we're going to do side. The key word is similarity with the squiggly line. So we learned this back in some chapters ago when two triangles were exactly the same size and shape. So if I had another triangle here, come on, triangle, and duplicate for me. Not delete, but duplicate. So if I had two triangles that were congruent, and they were congruent by the same sides here, this side is congruent there, these two, and the third side, I know that these two triangles are congruent by side. Congruent. That means the angles and the sides are all congruent. Well, the key word when I use side similarity, remember what we said before. On polygons, they have the same angle measure. It doesn't mean that their side lengths are congruent. So where these two triangles here were side congruent, that means their sides and their angles were congruent. On side similarity, where ABC is similar to PQR, I'd write triangle ABC is similar to triangle PQR. And remember, we use a squiggly line to show their similarity. And the key word for the key thing to remember about similarity, it means that their angles will be congruent. Their angles will be congruent. Does not mean that their side lengths are congruent, their angles. Okay? What's going to be true about similar triangles is that their side lengths will be proportional. So whereas QR might be 2, BC might be 6. Where PR is 4, that means that AC would be what? 12. Because we see that the ratio is going to be 1:3. How do I know 1:3? I'm doing small to large, and I'm seeing PQR is the small, and ABC is the large. PQR is 2 on this side, and BC is 6. Simplified is 1:3. Okay, if that's the case here, where this is 4, for PR is 4, that means that AC is going to be 12. 4 times 3 is going to give this 12. Okay, so again, this is side similarity. Their angle, all three angles are congruent. However, their side lengths are proportional. Not exact necessarily, but proportional. Okay, hopefully you have that copied. I'm going to erase this and come down. I'm going to take this a little example off. And actually, before I move too far, if we're looking at side, keyword similarity theorem, it means if two lengths of corresponding side of a triangle are proportional, then the triangles are going to be similar. What does that mean? If AB is proportional to PQ, AB proportional to PQ, and at the same time BC is proportional to what? QR, and finally CA is proportional to RP, then that means that triangle ABC is going to be similar to triangle PQR by, what did I say? Side similarity. The key word is similarity. If you only put side, 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 I'm thinking you're talking about the old one where it means the sides and the angles are congruent. But when I say side, 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 similarity, that automatically means that I'm just saying that the sides are proportional to one another. Okay? And notice what I did. I did the large triangle compared to the small. The large over the small. Large over the small. Okay? Now, know that this congruent figures, but the similar figures don't have to be congruent. They don't necessarily have to be the same length. I'll say that really quickly what I said before. Okay? AB is proportional to PQ. It does not mean they have to be the same length. BC is proportional to QR. Okay? Again, where I had the 2 here. It doesn't mean they have to be the same length. They have to be proportional. This is if I'm doing small to large, that's going to be a 2 to 6 ratio, or 1 to 3 if I simplify, if it were a fraction. Okay? So similarity means they don't have to be exactly congruent in length, but they have to be proportional. Theorem 8.3 is side angle side, similarity. Again, key word is similarity, and this is old. We did side angle side before when they were congruent. Now I'm talking about side angle side, similarity. Remember the difference between congruent. Congruent means that the 2 triangles had the same exact angle measures and side lengths. Similarity means they're proportional. The side lengths will be proportional. Remember, angles on polygons will be congruent. However, the side lengths will be proportional. Maybe a 2 to 3 ratio, a 4 to 1, something like that. But the angles will be congruent. Alright? Side angle side. If an angle of one triangle is congruent to an angle on the second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. What does that mean? I'm saying side angle side. I'm saying that ZX is proportional to PM on side angle side similarity. I'm also saying that the included, or the angle in between the 2 sides that I'm saying, are proportional. This angle X and angle M are exactly congruent, because on similarity the angles will be congruent just like they are on the congruent ones. What's the difference between congruent and similarity? Remember, congruent means the angles and the sides are congruent. On similarity, the angles will be congruent, but the sides will be proportional. So again, ZX is proportional to PM. Then I need the angle. Which angle am I talking about? Angle X is equal to angle M. And then the last side, XY, is proportional to MN. So side angle side. Again, this is going to be, the side will be proportional, angle will be congruent, and this last side again will be proportional. Okay? So proportional side, congruent angle, proportional side. Okay? Alright, so on this one, as I stated, I had if angle X is congruent to angle M, which I've shown, and angle, and then this needs to be moved over, PM Alrighty. So if I have my 2 angles, X and M are being congruent, then I have ZX is proportional to PM, and I also have XY is proportional to MN. Then that means that triangle XYZ is similar to triangle MNP. Right? And there's your 8-5 lesson.